All centrifugal pumps work by creating a centrifugal force. This force moves the liquid through the pump and increases the liquid's pressure. In applications where large increases in pressure are needed, multi-stage centrifugal pumps are often used. A multi-stage centrifugal pump contains 2 or more impellers and volutes in a single casing. Here's a simplified cross-section of a 3-stage centrifugal pump. Each stage of the pump has its own impeller and volute. In the volute, the liquid's pressure increases. Each of the first 2 volutes discharges into the suction eye of the stage that follows it. The 3rd stage volute discharges into the pump's outlet. So in this pump, the liquid flow path is from one end to the other. This is a 5-stage pump. It has 5 impellers and 5 volutes. The first 3 stages are located here, and the 4th and 5th stages are located here. But, as you can see, the liquid's flow path is different from that of the 3-stage pump we just saw. In this pump, liquid enters through the suction and flows into the impeller of the first stage. This impeller has a suction eye on both sides and is often called a double suction impeller. From the discharge of the first stage volute, the liquid flows into the second stage suction eye, then out of the second stage discharge and on to the third stage suction eye, and out of the third stage discharge to the suction eye of the fourth stage. The liquid from the fourth stage is routed to the suction eye of the fifth and final stage. After the liquid passes through the fifth stage, it leaves the pump through the discharge piping. Regardless of how the impellers on a centrifugal pump are arranged, or how many stages a pump has, the liquid's pressure increases as it passes through each stage. This creates a thrust across the impellers in each stage. This thrust, known as axial thrust, is caused by the difference in pressure between the suction eye and the volute. Because there is a difference in pressure across the impellers, axial thrust is created, and it tries to push the pump shaft toward the suction eyes. In order for the pump to operate properly, the thrust must be offset. On some pumps, the thrust is offset by using a thrust bearing or a device known as a balance piston or balance drum. On other pumps, the thrust is offset by the arrangement of the impellers. This pump has a balance piston. During operation, some of the fluid leaving the pump flows along the shaft and exerts pressure against the balance piston. That pressure tends to force the pump shaft away from the suction eyes and reduces the total thrust. Any fluid that passes by the balance piston is returned to the suction side of the first stage. Now on this pump, the arrangement of the impellers is used to offset axial thrust. Processed liquid enters the first stage impeller from both sides, so the pressures on both sides of the impeller are equal. The suction eyes for the second stage and third stage impellers face in the opposite direction from the suction eyes of the fourth stage and fifth stage impellers. Since the forces caused by axial thrust are in opposite directions, they tend to cancel each other out. As a result, axial thrust in this pump is kept to a minimum. In this topic, we looked at the basic operation of several types of centrifugal pumps, including single-stage pumps, vertical pumps, and multi-stage pumps.